So, welcome you all for another presentation. In today's presentation, just I am going to explain you about how the supernode concept will be used in another similar kind of example. So, this is also similar kind of example as we have discussed in our previous presentation. If you see this particular simple circuit, electrical circuit, it has different voltage sources as well as different resistors. And now the question is that find the current I. Okay, find the current, find the current I is flowing through the 2 ohm resistor, right? Using supernode analysis, using supernode analysis or supernode concept. Well, so for that, how to solve this actually? Say for example, if you apply directly the basic, according to the basic definition of the nodal analysis, then it may take little bit complexity. So by using the super node, it will be very easy. Why? Because what is the super node? Super node is nothing but the voltage source, the voltage source must be common between any two nodes. So therefore here we can consider this as V1, means node 1. Actually this is our node 1 where we have the voltage V1. This is node 2. If you take this as the node 2 where we have the voltage V2, right? Because in these two voltages, in between these two voltages, we have a 6-volt source is there which is common between two nodes. Therefore this path, this entire can be removed, disconnected, and can be considered as a common node, okay, or super node, right? So instead of considering these two, we can consider the whole as a common node or super node. For that we have to remove or disconnect this 6-volt source as we have seen in our previous example. In the same way we can see here also, right? So it is very simple. So now I am disconnecting this particular 6-volt voltage source. Okay, I am explaining the solution part of it. So for that, so just okay, you disconnect the 6 voltage source, then put a dotted mark there like that, no problem. Because assume that there is a circuit, whole circuit in contact, but so we have to disconnect the 6 voltage source, and by after disconnecting that voltage source, you have to assume that the entire whole circuit as a single circuit. Now we have to apply the KCL. Remember that we have to apply the KCL here. After disconnecting the voltage source, we have to immediately apply the KCL. That is the condition to remember. Okay, well, if you compare this particular example with the previous one, we have two current sources there in our previous presentation. If you recall our previous class, there we have two current sources, whereas in this particular we have voltage source here. So in this case what we have to do, so with this voltage source we have resistor and another resistor. Okay, with respect to V1 we have 3 ohm resistor, with respect to V2 we have 2 ohm resistor and then 6 ohm resistor. So with respect to 14 volts, assume that current I1 is flowing here, right? With respect to V1, assume that I2 is flowing here, right? With respect to this V2, assume that in 2 ohm resistor, call it as some I3, and similarly in this 6 ohm, assume that I4 is flowing. Like that we have to imagine. Understood? So with respect to 14 volts, assume that I1 is flowing. Okay, with respect to V1, I1, I2 is flowing. Okay, and then so with respect to V2, here through this 2 ohm, I3 is flowing, and again in this 6 ohm, I4 is flowing. Now for this entire circuit, we have to apply the KCL. So by applying KCL here, I can write the equation as like this. How this is the entering current. I1 is my entering current, that is it not? I1 is the entering current in general. Clear? I1 is the entering current, obviously. It is my entering current. I1 is equal to, then if you take the entire, this particular path or point as a common node, then from this particular point, I2 is going out, I3 is going out, I4 is going out, going away from the, node. I1 is the current entering to the node, whereas I2, I3, I4 going away from the node or leaving from the node. Therefore, you can write that here I2 plus I3 plus I4. This we have to write. This is your expression number 1. This is your expression number 1. So this is I1. Understood? This is a very important point to understand here. So I1 is equal to I2 plus I3 plus I4, right? And this implies, then what is our I1? How I1 can be written? It is again same, 14 minus V1. 14 minus V1 by 4 ohms. Clear? I1 is equal to voltage differences 14 volts. It is 14 minus V1 by 4. I is equal to V by R form. I is nothing but V by R. What is V? The total voltage or the difference voltage 14 minus V1 by 4. That gives I1. Similarly I2. For I2, V1 minus 0, because this is the ground line or 0 line. Therefore you can consider as these lines will be at 0 potential. Therefore your I2 is nothing but V1 minus 0. It is V1 minus 0 by 3. Similarly, what is I3? I3 nothing but V2 minus 0 by it is 2 plus what is I4? V2 minus 0 by it is 6 ohms, right? Now I am erasing this particular circuit. So this is what the important. Now you can simplify this particular expression and bring the relation for V1 and then V2, right? So I am erasing this, right? I am erasing this. So I am writing again here. This implies it is 14 minus V1 by how much? It is 4. This is equal to, simply this can be written as V1 by 3, right? V2 by 2, is it not? V2 by 2 plus it is V2 by 6. Clear? And this implies, and further simplify this actually. If you can simplify, because this V1 by 3 is there, here V1 by 4, this can be written as it is some 14 by 4, V1 by 4. I am expanding this, minus bring this V1 to the left side, then V1 by 3 you can write, bring this to this left side, and on the right side what you will have? It is V2 by 2 plus V2 by 6. Is it not? So simply uh, apply your LCM equation or whatever it is, then definitely bring the relation in terms of V1 and V2. V1 and V2. So by applying your LCM on both sides, and if you simplify all these things, the final expression I am going to write is that 7V1, the direct equation I am going to write here, you will get this one, 7V1 plus 8V2, 7V1 plus 8V2 is equal to 42. You will get this as the equation. Actually you will get, after the simplification of the above equation, you should get this one. Okay, you can call it as some equation number 2 or whatever it is, no problem. So 7V1 plus 8V2 is equal to 42. This is the expression you will get after by simply simplification. It is nothing difficult to simplify that. It is very easy. Okay, and then after that what we will do, so then now take the application of the KVL. Now apply the KVL actually. Okay, now apply the KVL. By applying the KVL, now this is the expression by using KCL. Now by applying the KVL, what we will get, you see the particular circuit. By applying, you can write like this, by applying KVL, we can write that it is V2 minus V1 is equal to 6 from the circuit. This is the equation number 3. because the voltage which we disconnected in the circuit, that is there between V1 and then V2. So the nodal voltages between V1 and V2, the 6 voltage is there. Therefore, that can be written as like this: V2 minus V1 is equal to 6. Therefore, from this expression, what you can write? V2 is equal to 6 plus V1, right? You can write like this for V2. V2 is equal to 6 plus V1. Give some equation number 4. And substitute this V2 value in equation number 2. Substitute this V2 value 6 plus V1 here. So if you substitute there, what you will get? You will get the value for V1 actually. Then you know what is your V1 value? You substitute V2 is equal to 6 plus V1 here, 8 into 6 plus V1. Then what you will get, So you will get your V1 as like this. By substituting that V2 value in the above equation, you will get as your V1 is equal to how much, It is something like this: 7V1 plus 8 times V2. What is V2 actually? It is V1 plus 6 is equal to 42. Is it not? From this you can simplify this and you can get the V1 value. So your V1 value must be something minus 2.5. It is something minus 2 by 5 will get. It is nothing but it is minus 4 volts. This is what your V1 value, definitely. This is what your V1 value minus 0.4 volts. And substitute this V1 value in the V2. What is that actually? V2 minus V1 is equal to 6 volts, and this implies V2 is equal to 6 plus V1 is there, no? So here you substitute 6 plus, what is your V1? It is minus 4 actually. So 6.4. How much you will get? Actually, how much you will get? So your V2 must be it is 5.6. It is 5.6 volts. So this is what your V2 value. So this is what your V2 value. So V1 is equal to minus 0.4 and then V2 is equal to 5.6. Now what is the current? Current where you are asking? Current I flowing through that 2 ohm resistor. Is it not? Current flowing through the 2 ohm resistor. So what is the current actually? What is the current flowing through the 2 ohm resistor? It is a I3 normally. So whatever the current I is flowing through the circuit is nothing but our I3. Is it not? I3. That is I3. We have. So therefore I3 is equal to what? What is the voltage there? It is V2. It is V2 by R actually. What is your V2? V2 is equal to 5.6 by what is R? It is 2. How much actually what you will get? Your I3 is equal to how much you will get? I3 is equal to something 2.8. 2.8 amperes. 2.8 amperes. So this is what your answer. This is what your answer. Okay. I hope you understood well, and we'll continue in the subsequent presentation. Right. Thank you.